which will entail this, then this is no longer weakest set. I'm sorry, opposite way. If there is another set of preconditions that you can get by with for A, such that the conditions that you picked actually entail those, then that means you are committing more. So for example, if I just said R and didn't say R or U, then if in fact R cannot be satisfied in this domain, there is nobody who gives R, then you will say this plan is dead. But in fact this plan could have been made to work because you could have worked on U.
What happens if there are two preconditions that are equally weakest?
Two preconditions, then both of them have to be considered. So that's basically the idea would be, that would happen for example, if in addition to A, you have a B, another action, which also can cause P and protect, violate Q, let's say. Then normally in that case, you throw A into a different branch and B into a different branch and compute these. And one of the interesting things is, even though I have disjunction here, actually I can split this disjunction into the search space. As long as my initial state is completely specified, the only way R or U would ever be satisfied is because, and so if you have deterministic actions and you have completely specified initial state, the only way R or U ever becomes true is because you know that R is true, or because you know that U is true. And so in fact, you can split the disjunction into the search space. Whether it's a good thing to do or a bad thing to do depends on this thing as to whether you have efficient constraint propagation over these disjunctions, in which case you want to keep them disjunct. Otherwise, essentially, to split it into the search space, what you have to do is take all of these and R into one branch, all of these and U into a different branch. Now, in fact, if there is this entire branch is going to fail because Q and not J cannot be satisfied together, you will figure that out the hard way twice, because it will fail in this branch as well as in the other branch. That's the disadvantage of splitting. You can always make search node, per node cost of search can be made arbitrarily small, but then you don't learn anything from one branch to another branch. And you can also make per node search cost arbitrarily large by not making up your mind, but then you will never be done. I mean, you will never know whether you are done or not. Even termination check can be full entailment check, for your particular logic. Okay? So that's what happens in regression. Now, in fact, when I looked at J, and I looked at J implies not Q, and said not J would be a precondition, that's essentially sort of confronting the enemy and stopping them from doing the bad thing. And so in partial order planning also you would need this. So if there is a threat that can come, if S1 is giving Q to S2 and this action can come in between, and it says if J then not Q, and if R then P, and it requires then basically in the partial order planning scenario, to even make A support P, you need to bribe it by giving it R. That was not one of its real preconditions, but to make it give A, now R has to be satisfied. Again, it would be an open condition that needs only to be true at A, not otherwise. And similarly, since A can be potentially between S1 and S2 in this particular picture, okay, to make sure that it does not violate Q, you have three possibilities. You can either get A, make it come before S1, get A, make it come after S2, or leave it where it is and say not J is an open condition. Not J will be a required precondition. Okay, so this is confrontation, or A before S1 or S2 before A. Those are the three options. That's what happens when you handle conditional effects in partial order planning. So you have an extra resolution possibility. What happens if you miss that? Basically, you could lose soundness. I mean, you could lose completeness. You won't lose soundness, but you could lose completeness. There may be the only plan that is there requires you to confront. Okay, and so for example, there's a classic example of briefcase, carrying stuff by briefcase to some place. Okay, so the way you could do it is that when you are carrying it in briefcase, if the briefcase gets opened, things will fall out. That doesn't mean you should carry it, you should just close the briefcase so that it won't fall out. Do you see what I'm saying? So the confrontation has to be considered, otherwise you lose completeness. Okay? So the other interesting thing is, even if you started with just positive sub-goals, remember I said one kind of thing that people tend to think of is only positive preconditions. The simplest version of strips is only positive preconditions and adds and deletes. Now even if you started with that, if you have conditional effects, in confronting them you will get negative preconditions. So it's like a historic footnote that first time people paid attention to negative preconditions, that means preconditions which say certain things should be false, was when they had to deal with conditional effects, because until then they could get away thinking, oh, any reasonable domain will only have positive preconditions. I think that's a bogus argument to begin with, because there is true is no more interesting than false as a value for a Boolean variable. Okay, but if you had that mindset, then you would have changed it by this time. So that's what that says. The last thing that I would do, and interestingly I won't get to planning graph today, I'll get to planning graph next week, and then the class after that we'll do landmarks. The last thing we need to think of is what happens if the action is partially instantiated. And the idea essentially is, if you in fact and when you start thinking of partially instantiated actions, then the advantage is in essence you're doing lifted reasoning. So for example, suppose you are in the blocks world. Suppose you are in the blocks world where I need A to be clear. Okay, and B is on top of A right now. And I want, initially B is on top of A and A needs to be clear. Okay, so I would say, well, since you want clear A, I need to put an action which gives clear A as an effect. One idea is basically saying put B, which is currently on A, from A to where? X, I'll say. Because I don't really care where I put B. I just want it to be off my head so that I can be clear. So to actually make this guy cause clear A, all I needed to do is put B from A to some X. And I don't need to make up my mind as to what that X is. Do you see what I'm saying? Okay? And that's basically reasoning with partially instantiated actions. And that will reduce the amount of commitment you need to make. And the more commitment you make, the more backtracking you need to make. Remember, going back to the PhD student, if you commit to an advisor, you may actually have to cut out of that commitment. If you never commit, then you will never have to say, I don't want to work with you. You may not get a PhD, that's a minor detail, but you will at least not have to work with anybody. Okay? So in this particular case, I don't commit, so I leave X unbound, and the advantage of that is then if I'm now trying to see if this plan done already. So for example, think about what's the advantage. Suppose I could do it this way, or if I have to consider all the ground actions, then I have to consider in different branches, put B from A to D, put B from A to M, put B from A to K, blah 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 blah. And then see which of them actually works. And it depends on the initial state. In the initial state, if in fact M basically already has somebody on top of it, then you can't put B on top of M. And of course you can say, well, since somebody is sitting on top of M, first I'll remove that guy from M so that I can put B. And by the way, I'm not making this up. It's not just the end of the class and I'm retired or something. Planners do this exactly. Once you get set, you will work. You have a good causal reasoning as to why you are clearing. I mean, I'm sure as kids you would have seen these kinds of causal reasoning stories. I'll send you one which I read in my first standard about these kids of a king who go and catch some fish and then try to dry them, and then they don't get dried, and the whole story is the entire causal chain as to why they didn't get dried. And they ask the fish, why didn't you dry? And they say, the fish say, well, because we got stuck in a shadow of a big pile of grass. And they ask the grass, why did you come in between? It says, because the cow isn't eating me. And they ask the cow, why aren't you eating? And you see what is going on. So it's like there's an entire causal chain. Kids understand causality. That's why they were telling me this in first standard. Okay. So sometimes the causal chain might locally is consistent, but globally you might think, why the heck are you doing this? Why are you clearing up M just so that you can put B on top of M? But you're set in your ways. Are you going to do it? In this branch, it's better to, so for example, one other thing that you could do is suppose, I'm somehow in this PhD mode today. Suppose you decided to work with some guy, now it's too late. You already got a cushy desk with this guy as the advisor. You don't want to go to this other guy who has much more crowded office. The only minor problem is the advisor is not interested, let's say, in type theory, which is what you are interested in. So you try to make them be interested in type theory. You change your advisor. Right? And you might be wondering, instead of doing your PhD, why are you changing your advisor? Well, I had a good plan. I needed to get a type theory dissertation. I have a good desk and all that. My advisor doesn't know type theory. I'll change my advisor. Now, globally speaking, you might say the right thing to do is backtrack and go to this crowded office who does, it's right across from you, which the advisor is a type theory guy, work with them. But you can do that either if you backtrack or if you didn't, commit prematurely. Okay? So in this case, because not committing prematurely, I can look at the initial state and see which X is available, and I'll put B on that X. Do you understand what I'm saying? So that's the advantage of lifted planning. Okay. Now the interesting thing, of course, is when I have these variables, there is again, as I said, if you don't make commitments, you don't have to backtrack, but you may never actually know that you're done. Okay. So after a while, you will have a put BAX, put BAW, put BAM, and there are like 18 variable blocks, and your problem has 3 real blocks. Do you understand what I'm saying? Right? So somewhere along the line, if all of these guys are supposed to be independent blocks, but there really are only 3 good blocks, so you're dead. You have to realize that you're dead rather than expand it to make one more J and K and M and L blocks, which are also existential variables. Okay? And to do that, what do you think you would need to do to actually realize that the node that you have on your hand is dead? You need to solve a simple CSP problem. A CSP problem says, here are real blocks, here are variables, these blocks can take values from these variables can take values from these blocks, and there are some non-codesignation constraints. This variable and this variable can't be the same block. If I throw in a bunch of codesignation and non-codesignation constraints, then it becomes a finite domain CSP problem, which just happens to be NP hard, NP complete problem. Okay, but I do want you to think about how to handle lifted actions, because my belief is supporting lifted actions will actually improve planning, and in fact this could make a good class project for any of you who might be interested in this, because most of the existing planners just work in the ground level. I'm telling you why it could fail, why also it could work. So finding the right golden mean, the right amount of least commitment over the variable values. Okay, so this one is telling you how to do regression when you have variables, and this one is telling you how to do partial order planning when you have variables. In the case of partial order planning as well as regression, you would wind up doing this co-designation and non-co-designation constraints. So you would say a certain variable must be having this value, that this variable cannot have this value. So for example, if there is a put BAX, and apart from clear A, I also have clear J as one of my goals, then this guy is threatening to kill J. But I don't need to make it K, I don't need to make it C, the block C, just so that it won't kill J. I only need to make it not J. Did you see the beauty of it? Now I'll just say, in the previous state, X is not equal to J is one of the constraints. And now in any particular regress state, you have a bunch of these constraints hanging around, and you have to check whether they're still satisfiable. If they can't be satisfied, then it's a dead node. And the worst thing you can do in search is to expand a dead state, because it will then give you dead children, dead grandchildren, dead worlds, and you would be dead. Okay. So, and then in the case of a scenario where you, for example, let's say you have a causal link and action A says I will delete P of X, and you are trying to support P of M. M is a constant. Then what you need to do is P of X is sort of like a conditional effect. So you basically say I'm going to delete somebody, okay, and you say just don't delete M. So you will say X not equal to M. That's an unco-designation constraint. And that's actually called, just as adding the negation of the antecedent is like causation, it's a preservation precondition. This is called separation as a resolution. So you can promotion, demotion, separation, confrontation. Those are now 4 different ways of resolving a conflict if you also have partially instantiated variables. What you want to understand when you go home is, why would you care about partially instantiated variables? It's because you don't need to, essentially, ever since you were born, you're trying to get away from states, atomic to propositional, propositional to relational, relational to first order. And if you know how to do the reasoning efficiently, there is a lot of advantage to be gained by not making premature commitment. So we'll stop here. Okay. So have a good Labor Day, and then I'll see you next class.